Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code B0072-11 signifies a fault in the front passenger's seatbelt tensioner system in the 2011 to 2017 Honda Odyssey. This specific code is related to a short-to-ground condition, which indicates that an unintended connection to ground exists within the wiring or components of the seatbelt tensioner. The seatbelt tensioner is an essential safety component that tightens the seatbelt upon vehicle collision to prevent occupant movement, thus reducing injury risk. Its location is on the front passenger's side, often near the lower part of the seat structure or within the B-pillar. Diagnosing the issue effectively not only involves checking the wiring integrity, but also understanding the role of the SRS, Supplemental Restraint System, in enhancing passenger safety during an accident. The DTC B0072-11 specifically involves the front passenger seatbelt tensioner, which is a crucial safety feature designed to enhance the effectiveness of seatbelts in a collision. This component functions by retracting the seatbelt to secure the occupant tightly during an impact. The tensioner usually mounts on the right side of the vehicle, closely associated with the B-pillar, which is the vertical support that helps frame the vehicle's body. If there's a short-to-ground condition, it could be due to damaged wiring, a defective connector, or an issue with the tensioner itself. It is critical to address such errors promptly because they directly impact passenger safety in the event of a collision. Therefore, troubleshooting this DTC requires careful attention to both the tensioner's operation and its wiring harness. The potential causes for the DTC B0072-11 fall into several categories. Damaged wiring harnesses can occur from wear, corrosion, or physical impacts that may expose wires or create shorts. A defective connector may also lead to connectivity issues, unable to deliver or recognize signals appropriately. Occasionally, the seatbelt tensioner itself may be at fault, especially if it has been exposed to previous collisions where its functionality might have been compromised. Additionally, any previous collision involving the vehicle should prompt a thorough inspection to ensure that all necessary components, including the tensioner, were correctly replaced and installed. Diagnosing and addressing these possible causes is crucial to maintaining the effectiveness of the SRS. Symptoms associated with DTC B0072-11 usually manifest as safety alerts within the vehicle. The most overt symptom is a warning light on the dashboard, indicating a malfunction in the SRS, which might suggest issues with seatbelts or airbags. Owners may also notice that the seatbelt does not operate correctly, failing to tighten or secure passengers as intended. A critical symptom can occur where the tensioning mechanism does not activate during an impact, thus jeopardizing passenger safety. Furthermore, the overall performance of the airbag system may degrade, leading to potential failure during a crash. Recognizing these symptoms early can significantly enhance safety and prompt timely repairs. The initial troubleshooting step involves clearing any diagnostic trouble codes, DTCs, using the HDS, Honda Diagnostic System. This step is vital prior to further diagnostics as it resets the system and allows for the identification of any current active codes without the influence of historical codes. The HDS is a specialized tool equipped to communicate with the vehicle's onboard computer systems, providing diagnostic insights. After clearing the codes, wait for about 10 seconds to ensure the system is stabilized before proceeding. This ensures a clean slate for retesting, allowing technicians to determine if the issue persists. This step is crucial in identifying intermittent problems that may not be present all the time. Upon clearing the DTCs, the next step is to turn the ignition switch to the on position. or in models equipped with a push-start button, press it to select the on mode. This action powers up the vehicle's electronic systems, allowing sensors and modules to initialize. After switching to on, it is essential to wait for at least 10 seconds, as this duration permits the system to perform self-checks and stabilize. During this period, the onboard diagnostics will run preliminary checks to ascertain the system's readiness to detect any potential faults once again. After the waiting period, you will then need to check for the presence of any DTCs using the HDS, thus enabling a structured approach to identifying current issues. The third step involves checking for any DTCs using the HDS after waiting 10 seconds. This is a crucial part of the diagnostic process, as it determines whether the previous issue has been resolved or if B0072-11 remains active. If DTC B0072-11 is still indicated, this suggests that the underlying fault has not been rectified and further action is necessary. However, if no DTCs are present, it may signify an intermittent failure. The system is functioning correctly in that moment. Should another DTC appear, you must address and troubleshoot that specific code, as it may point to a different issue that needs to be resolved. This process ensures that all aspects of the SRS continue to function properly and reinforces the safety protocols of the vehicle. After determining whether the DTC persists, the fourth troubleshooting step requires you to turn the ignition switch to the lock position or press the engine start-stop button to select the off mode. This action powers down the vehicle's electronic systems and is a necessary protocol before working on electrical components to prevent any damage or accidental deployment. Turning the ignition off also allows you to safely interact with the vehicle's wiring without the risk of electrical shorts or injury from live circuits. It is crucial to ensure that all protocols related to the SRS, Supplemental Restraint System, are observed at this stage, prioritizing safety for both the technician and the systems involved. The fifth troubleshooting step involves disconnecting the negative cable from the vehicle's battery, a pivotal step when working on SRS components. This procedure is crucial for ensuring that there is no current running through the circuits, thus preventing accidental deployment of the airbag or tensioner and minimizing the risk of injury. It is important to wait at least 3 minutes after disconnecting the battery, as this gives the vehicle systems time to fully discharge and reset any stored voltage. During this waiting time, it's advisable to review any previous diagnostic actions or observations. This precaution helps ensure that when you reconnect the battery, the systems are adequately prepared for further testing or repairs. The sixth troubleshooting step requires removing the right side B-pillar lower trim. This trim piece is typically located along the vertical support structure next to the passenger door. Removing this trim is necessary for accessing the wiring and connectors associated with the front passenger seatbelt tensioner. Proper removal involves using appropriate tools to avoid damaging clips or the trim itself, ensuring the process is as non-invasive as possible. Once the trim is removed, you gain direct access to the critical components located behind it, allowing for further diagnostics to be performed on the seatbelt tensioner system without interference from obstructions. It's important to keep track of all fasteners and components during this step to facilitate reassembly. In this seventh step, you will disconnect the front passenger's seatbelt tensioner 4P connector from the right side wire harness. This connector interfaces directly with the seatbelt tensioner and is crucial for its functionality. Inspecting this connector for any signs of damage, dirt, or corrosion should be part of this step, as even minor disruptions can impact the tensioner's performance. When disconnecting, it is essential to handle the wiring carefully to avoid any inadvertent damage. Taking care during this step plays a significant role in the safety and reliability of the SRS system, as any faults in the connector can lead to improper seatbelt tensioning mechanisms or faults that could trigger additional DTCs. Proper documentation of this step can help track progress throughout the troubleshooting process. The 8th troubleshooting step involves connecting the terminals of the SRS simulator lead K to the seatbelt tensioner using an SRS inflator simulator that has 2 ohm connectors. This step is crucial for simulating the tensioner's operational environment, allowing technicians to test whether the circuit may be functioning appropriately without deploying the actual unit. Proper connections should be secured to avoid any loose connectors that could compromise the simulation results. Evaluating the tensioner under these conditions helps ascertain whether the issue lies within the tensioner itself or the wiring and connectors leading to it. Using the simulator also helps isolate the problem, aiding in accurate diagnostics, which is crucial for implementing the right repair strategy. The 9th troubleshooting step is to reconnect the negative cable to the vehicle's battery, restoring power to the vehicle's electrical systems. It is essential to perform this task safely to avoid sparks or shorts, which could damage electronic components. Ensuring a solid connection when reattaching the negative cable is crucial, as a weak connection can lead to further electrical issues or DTCs appearing in the future. Once reconnected, it will enable diagnostic tools to communicate effectively with the vehicle's systems, allowing for subsequent testing and troubleshooting steps to be executed. Properly observing this procedure facilitates a seamless return to operational status for the SRS systems and aids in identifying persistent issues within the seatbelt tensioner circuit. The 10th and final troubleshooting step is to clear the DTCs once again using the HDS. This repeated action is important to verify the results of the previous steps taken in diagnosing the DTC B0072-11. Once the codes are cleared, it's critical to allow the systems to stabilize and recheck for any persistent issues or the same DTC. Successfully clearing the DTC without recurrence indicates that the problem has been effectively resolved. If B0072-11 reappears, it may indicate that further investigation is necessary, either in the form of further component testing or addressing the wiring harness for potential shorts. Engaging to this final step validates the effectiveness of the troubleshooting process conducted and reinforces overall vehicle safety. Final repair verification is essential after troubleshooting the DTC B0072-11 to ensure that all systems are functioning correctly. This phase involves checking all safety systems, particularly the SRS, to confirm that they respond appropriately and perform their intended functions. If the vehicle was subjected to heavier conditions, a road test may be prudent to validate that the seatbelt tensioner and airbag systems engage as expected during normal driving conditions. After road testing, rechecking for DTCs again serves as a quality control measure. It ensures that the previous issues were conclusively resolved. Documentation of these steps should be kept for record keeping and future reference. This verification process enhances overall safety and builds confidence in the repairs performed. Preventive maintenance is crucial in ensuring the long-term reliability of the SRS system in the Honda Odyssey. Regular checks of the SRS system should be part of vehicle servicing, focusing on all wiring and connectors associated with the airbag and seatbelt systems. A visual inspection of components can help identify wear and tear, corrosion, or any physical damage that may arise over time. Additionally, it's essential to update the SRS unit software whenever a new version is available. Doing so enhances the performance and functionality of the systems involved. Keeping detailed maintenance records allows for better tracking of service history and can alert technicians to potential issues based on historical data. By following these preventive measures, vehicle owners can help maintain safety and prevent unexpected issues with the SRS. In conclusion, understanding the nuances of diagnosing DTC B0072-11 is crucial for automotive technicians working on the Honda Odyssey. Each step in the diagnostic process contributes to enhancing passenger safety by ensuring the SRS system functions correctly. This includes verifying the integrity of vital components like the seatbelt tensioner and associated wiring, while also recognizing the importance of readiness checks and software updates. Regular maintenance plays a pivotal role in safeguarding against faults that could compromise safety features in a vehicle. By adhering to systematic troubleshooting and preventive measures, both technicians and vehicle owners can significantly enhance not just the reliability of the SRS systems, but also the overall safety of the vehicle on the road. Please like and subscribe to the channel. See you next time.